Here's part of Jakob Nielsen's keynote address at the NNG UX conference in Las Vegas.
Now let me turn to the second topic, which is how do we maximize the insight we get out of doing user research? And there are really kind of two things that one typically looks at in doing research, which is reliability and validity of the study. So reliability is the question of, if I do the same study a second time, will I get the same result? If I do the third time, do I still get the same result? If I do it 10 times, do I get the same result all 10 times? Yeah, this is very important, because if you get the different result every time we try, then it's just random. We might as well flip a coin and it's not of any good. So we do want reliability. But we also want validity. Validity is, do the findings mean anything for the real world? Not just for the research world, but for the real world. And reliability we can operationalize based on these probabilities, and the people who are going to the measuring user experience course will have a lot of details about how to do this. But we have very good formulas and ways to operationalize reliability and say whether something is statistically significant or just random. Validity, on the other hand, we don't really have. So I would like to operationalize validity as saying, if we make a business decision based on this research recommendation, are we actually going to make more money in the company? Is it actually going to work? Does it move the needle in one of those cliches? And I think that is at least as important as reliability. Because if you study something that doesn't make translate to the real world, it's also falls for nothing. And there's so much attention to the reliability. And I think it's because we do have great formulas for calculating it. And so people often forget about the validity. And I think this is very similar to this old anecdote about the drunk guy who's looking for his lost car keys under the street light. And the police officer comes around and says, what's happened? Oh, I lost my car key. And the police officer tries to help him find the keys, and they can't find it. Finally, the police officer turns to the drunk guy and says, are you sure you lost your car keys here under the street light? And the drunk guy says, no, I lost them over in the park, but it's easier to look here. Because it's like, I think it's the same here. It's easier to think about reliability because we have a very firm handle on that concept, really great formulas for looking at it. And then people often forget about validity. And particularly when you think about the way that reliability is usually thought about, it's usually thought about in terms of things like statistical significance, which we usually like to say, well, if the P, which is the probability, is less than 5%, then we'll say this is a good research finding. But think about that. That really means P is a probability that it's just a random outcome. So this means that if I do a study, if I do 20 studies, 19 of them is the right finding and one time is the wrong finding. Well, if I'm doing it for my website or for my project, then this is pretty good odds, right? 19 times out of 20 studies, I'm going to give you the correct recommendation for what to do. One time out of 20, I might give you the wrong recommendation. This is still so much better than just guessing, which means half the time I'm giving you the right recommendation, half the time I'm giving you the wrong recommendation. So for any individual problem, those odds are good, and this is why 5% is sort of the usual recognized number you do for reliability. But if you think about the world, not your product, but the world, right? There are thousands upon thousands of user research studies being done every year, and both people do them confidentially, but also people do them for publication in various places. And that means that 1 out of every 20 research papers you read is a bogus finding. And now it's much worse, and it's actually even worse than that, because what do you hear about? So all the people who do a research study and their finding comes out the same as what we already know and expect, you're not going to hear about that. So let's return to, let's say, banner blindness. So somebody else does a study about banner blindness, saying, oh yeah, banner blindness is there. That's not going to get like big hyped up and be covered everywhere and like get millions of tweets and everything, right? So you don't hear about those studies, but you do hear about the studies that come out with some weird, unknown or previously not expected finding, which is very often wrong. Like, for example, take the question of response times, of how fast your, let's say, your web pages appear. So basically, almost every study ever done of this shows that response times are important. The faster the website, the more you do your business. E-commerce side, they can see the sales go up. Google can see people do more searches. I mean, everybody who studied it almost will have this finding. So if one more place goes and does a response time study and says faster web pages are better, you're probably not even going to hear about it. However, I think about 10 years ago, somebody did a study that says response times don't matter, and that got a lot of attention at the time. And so that's one of the problems about just kind of relying on the statistical analysis, because if the P number says that it's only very rare that this would be a bogus finding, yeah, if it's only your own project, fine. But if you look about all over the world, tens of thousands of studies, there's going to be a lot of bogus findings there. You're going to hear about often the wrong ones. So my recommendation for how to deal with that is that you kind of imagine one of these old kind of balance scales, and you put all the research findings that says one thing on one scale, like I said, all the findings that says response times are important, this big list. And over here you have the other balance scale, and you put that one study that says response times don't matter, then you let the balance scale come out and says, whoa, this is so much more heavy evidence. This is the evidence you should trust, not this little tiny one thing. So that's one way of dealing with that. And so you can very easily be led astray if you think about only about statistical significance. So let me ask you, what I just talked to you about the study we did about websites in 2016. What makes that an interesting study? Why did I tell you about it? It's because we had more than 1,000 data points. It's because we had more than 200 users, more than 200 tasks, 43 websites, and we tested in 2 different countries. Which of these numbers makes this a good study? Well, the 1,000 data points means that our statistics and numbers are kind of reasonably tight, so that's good. But what I think really makes this a study where the results are interesting is actually the 43 websites and the 215 different tasks, because it's a diversity that makes this generalizable. This is not just like on this one website for some weird unknown reason, people couldn't find what they were looking for. This is across a broad set of websites from different industries, and where people tried many different things. Not just they tried one thing and they couldn't find it. It's they tried many things and they often couldn't find it. That's what makes it believable. So I really want to encourage more diversity in research and trying different things, not just kind of like trying one thing. It's an enormous, huge N. So N is kind of like the number of users typically, and that's what a lot of people fit. That might almost like the only thing many people care about. And I think that's the least important. You want to look at how many different things were tried with how many different designs. Another example from another thing we did. We did 5 different studies of mobile text comprehension, and Kate Meyer led that project. So what's this basically studies? A remote study with 20 users and 4 articles, another remote study with 25 users and 6 other articles, a lab study with 37 users, 8 focus groups, or another remote study with more than 200 users. Well, it's a little bit of a trick question here, because actually what makes this the best is all of them. Because what happened was that they all came out with the same result, and the result was that text comprehension is actually either the same or slightly better on mobile than it is on regular computers, which was a big surprise to us. Because back in 2010, other research had found that text comprehension is much worse when reading from mobiles than when reading from desktop screens. And so when we did our first study with like the 20 users, and the study came back saying, and the results came back saying completely opposite result of the old research, I just said, I don't trust this. So let's go and do another study with some other articles, just maybe these 4 articles, there was something weird about them. Let's do another study. Okay, same result. Now I thought, so we did these 2 studies with UserZoom, which is a platform for remote studies that we use a lot, and we've had good results with it, but that said, I was just thinking, well, maybe there's something wrong with UserZoom in text comprehension. Maybe it works for like e-commerce studies, but not for text comprehension studies. So we dragged people into the lab and we watched them while they were reading these articles. It was a rather boring study, but we watched them while they read the articles, same result. And then the focus was more like talking to people of how they read stuff. So that gave a sense of, oh, it's really nice to read a mobile. I usually do that. I like reading on my phone a lot. And then finally, a more big sample size to see if we could nail the statistics down, and again, same result. Now, so why is this? Well, I think one big explanation is that if you think about what was a phone in 2010 and what's a phone now, current phones have 6.5 times more pixels on the screen. So, one thing is comprehension on this little crummy screen, another one is on this kind of, still not big, but much bigger, much better screen. So that's at least one possible explanation. But in any case, my general point was, our result was like the opposite of the old research. You should not trust that. When something is like, it used to be A, if you do a study that says now it's B, that is usually wrong. Usually you're going to be in one of those 5% cases where you happen to be wrong, but this does happen from time to time. So if you do a study and it's the same as you expect, then you can kind of be, okay, let's move on to the next thing, because you can't spend endless resources on every single problem you have. But if you do a study and it comes out opposite of what all previous studies show, then worry that maybe something's wrong with your study. And then I said, then do it again and do it in a little bit different way and see if you still get the same. And after a while, yeah, we can trust that things have changed in the world, but not the very first time you do a study that's different than anything else. Okay, so I wanted to emphasize this point about diversification in the research, such that we don't just do one thing and kind of go by that. And so there's a variety of ways in which we can diversify it. So one of them is just different people. And we do want to do that because we do know people are different. So if I just take one person and have the user decide, can we go by that, what happened in that one session? Probably not. Could be just a weirdo. That happens. So we do want to have more than one person, but if we crank it up, hundreds of people, thousands of people, usually it's not worth doing. It's more important to have different personas and just different individuals. So in other words, different types of people. And what we say, if anybody went to the personas class today that Kim taught, is that it's more important to have behavioral differentiations, or have personas that are defined by people's behavioral characteristics and their demographic characteristics. Because usually, for the type of things we look at in user experience, there's usually not that much difference between demographic characteristics, let's say like age or gender or location, if they're in one city or another city. They usually tend to be kind of about the same. For other type of market research type of things people might want to do, that could be important, but for our type of interaction research, behavioral characteristics such as the job, their computer experience, their technical skills, they tend to be more important. But also diversify, not just with the users, but also with what you are testing. So test different designs, not just like your one best idea, but test your 5 best ideas. I have 5 different designers, each come up with their best idea and test that. That's a much better way of getting insight into what is going to be the best solution to your design problem. Try to have people do different things, not just one thing, but a variety of different things. And finally, also try to employ different methods. So I am, such a super advocate of usability testing, and I'm putting a user down in front of the computer and have to see what they do. Yes, but there are also a variety of other methods we also want to use. And use measurement methods, use qualitative methods, use a bunch of different things, and they all kind of together will help you get a much richer insight. And rather than doing the same thing and again and again and again, and so pouring, the gold into this one part or this one approach, try to spread it out a little bit and get a little bit more of different types of insights. It is also worthwhile having good methodology. So here is a chart that shows a project I did a while ago where we actually had 20 different teams do the same study, which is not something we usually do, but in this case, 20 different teams all tested the same software product, which had 8 kind of serious design problems in it. And the dots show how many, on the y-axis, how many usability problems that team found, and on the x-axis, we kind of rated how well they did the study in terms of all the recommended ways of doing usability testing that people would have heard if they went to the course we had a few days ago, I think. Or maybe it's not even the course on usability testing anyway. And what you can see here, there's a pretty strong correlation that the better you run your study, the more you follow the methodology advice, the more you will actually learn about your software. That said, it's not 100% correlation, and also, even the worst teams that only did like one-fifth of what's recommended, that's really a bad study, they still found 2 out of the 8 things. They still found a quarter of the things. And if you think about it, if you're doing product development and you can like remove a quarter of the really bad things in your design, that's still worth doing. I mean, certainly more worth doing to do a better study, which is why we do have courses on how to do usability testing right. But even a bad study will still be worthwhile and we'll still find something. So really go and do this stuff. So to conclude, I want to show you a painting that I saw in London here. We had our conference in London a few weeks ago. The title of the painting is Man Proposes, God Disposes. And it's from 1864. And it shows what the artist imagined happened to Sir John Franklin's polar expedition. And so that was lost and never heard from again. And so the artist sort of imagines, you can see that the polar bears are gnawing on the remains of Sir John. And so that's what happens. So the man, in this case Sir John, proposes we'll go and explore the Arctic regions, but God says, no, my polar bear should have something to eat. So, so that's a nice little moral lesson there from the Victorian age. But I want to use this sort of as a little metaphor to think about our world. Because in our world, the similar slogan would be, designers propose, but users dispose. So you propose something that says, this is going to be such a wonderful design, yay, yay, yay. And then users say, man, I can't use it, I'm going to go elsewhere. And so we still have that kind of reality check of facing up with nature, in this case, nature being the users, not the polar regions. And we have to be designed for reality. So designers propose, but users dispose. So you better do your user testing or your design will be eaten by polar bears. Thank you.